What is DAX? The acronym DAX or DAX stands for Data Analysis Expression Language. This is the query language for a tabular model in the Analysis Services 2014 instance. Query language was originally created for Excel Power Pivot and was ported to Analysis Services when they upgraded it to an enterprise-level tabular model. Its uses vary. The first one is for computed columns, and this is at the row level. You add this in your tabular model. The second one is for measures, which can be in the syntax of a query or in the tabular model itself. And that measure at the model level has related tables, which are usually the dimension tables. Reporting tools such as PowerView or Excel can connect to a tabular model and execute the DAX language. And lastly, it can be used to create row-level access security in the enterprise system. To be able to understand how to use DAX, first you need to understand the data model. We will do a brief overview of this, but in previous modules you were able to create a tabular model from scratch. First, let's talk about this model. It is different than the multidimensional cube where we talk about a cube space. The tabular model is designed around tables, both the fact and dimension tables. We still want to use a dimensional model for best results in a tabular model. And relationships. Relationships are best built into the model, but you can use DAX to create a relationship, though there's not many reasons to not have the relationship built in the model. The join between any two tables in a tabular module is always a left outer join. It will always grab everything from the one side and also do some sort of aggregation for the many side. The relationships are designed one-to-many, though in future versions you should be able to have it many-to-many and bidirectional. One-to-many means, as an example, that there is one product to many cells for that product. Or the date relationship of order date, there is only one order date inside of the cells. Now let's go ahead and review parts of the data model. In order to do that, we're going to open up a previously designed tabular model. I'll launch the SQL Server Data Tools from an icon on my desktop, or you can go to the Start menu. Then I will open up a previously designed Analysis Services tabular module. Once it's open, the Solution Explorer shows us the model BIM file, which is where we're going to examine tables and the relationships. I'm going to pin down the Solution Explorer so we can view a little bit more. Here we have each table: customer, date, product. Disabled or hidden from the client tool is category and subcategory, other dimension tables, and then eventually we get to internet sales. So the dimensions and fact tables are both managed in the same area. They're managed tabular just like Excel does. You also have the measures that are calculated in the lower area, which actually uses some DAX. Here you can see internet sales is a DAX function. It's the sum of sales amount, and in this case it's summing for the whole table. If we go to gross profit margin, which is a calculated column, we can see sales amount minus total product cost gives us a gross profit on each individual row. This is the row context. Next, in the lower right, we'll click on the grid view or diagram view. Here is where your tables and their relationships exist. We're going to double click the one on employee to reseller sales, and it's going to bring up the edit relationship dialog. Here on the left we see that reseller sales and column employee ID is related to the lookup table, employee, and employee key. Also, we'll notice that it is active. Here, the employee is the one and the reseller is the many. There's only one employee for each individual reseller sales, but an employee can have more than one sale. Also, there could exist no sales for any particular employee. That's where the left outer join comes into play. So now let's look at the DAX structure. First, we'll look at the evaluate statement. The evaluate statement is like creating a select T-SQL statement in the database engine. Alone with the name of the table can be like a select star from table name, as in this example. Here you see evaluate product, and it lists all the columns in the product table along with their values. To access the measures in a tabular model and apply the group by characteristics, you have to include the summarize statement with the evaluate to use these measures, or calculate your own measures. You can calculate these measures using an aggregate as a DAX expression. The group by is what slices the data by an attribute of a dimension. In this example, you can see evaluate, summarize reseller sales table by or group by product category, and then display the reseller sales measure. The filter statement lets you apply context filtering on the expression, and you can follow this expression by one or more filters. And in this example, we're going to evaluate and summarize. We're going to use the filter statement first because the first part of the summarize is a table, so we're filtering the customer table where the gender equals M for male. Then we're going to display the customer full name, the customer gender, and then create in the summarize a column called sum of sales. In the DAX expression, sum internet sales with the brackets around sales amount reference the table and column name from the internet sales table. And our results show us we get the full name, gender, and sum of sales. You can also apply an order by to this summarize statement to summarize by, say, sum of sales or full name. There are some other DAX peculiarities, and one of them we'll talk about first is the addition. Some other items have to be aware of this plus or ampersand signs. The plus will add two values together and will try to convert a text if between the plus sign to a numeric if you use that. Here we have in double quotes 1 plus 10 in double quotes. What we would think is that this would come out to be 11. And that's exactly what happens. DAX converts those two to numeric based on the plus sign. Now we'll look at the concatenate, which is the ampersand. The ampersand will concatenate two text items together, converting numeric to text. In this example, 1 ampersand 10 does not give us 11, but actually gets us the character 110. This implicit conversion will happen if you don't apply the text to the ampersand or the numeric values to the addition sign. So now let's look at a demonstration of using the DAX syntax. First, we'll launch SQL Server Management Studio. Here, we're launching it from our desktop as an icon, but you can launch it through your Start menu, and then we'll connect to our default instance for the tabular module. Next, we'll go to the database that we want to query, which is our VentureWorks DW14, and we'll create a new query. Let's hide the Object Explorer and maximize our screen so we can start entering DAX. The first one is just going to be a select on a table. we'll start with evaluate, open parentheses, and provide a table name. If we run this, which I'm just pressing the F5 key, or you can click the execute button, we can see we get a list of the product table. If you notice on the right, it really references the model like an MDX query. So here it actually says we're using MDX, but we're really using the DAX language. You can actually execute the MDX language on a tabular model. We're not going to do that. Next, we're going to summarize reseller sales. So we're going to introduce a new iterator, and that is going to be summarize. You notice I'm spacing some things out. It's not necessary, but this is good for readability. And we're going to actually summarize the reseller sales table. And then place a comma. Our next thing is to reference the actual name we want to call this column. We'll say reseller sales. And then we want to provide the column name, or the actual column or measure from the table. We'll use the bracket and reseller sales. Close that bracket, then close our parentheses for summarize, and close our parentheses for evaluate. We'll highlight that statement and execute it, and now we get a total reseller sales from the reseller sales table. Since we didn't provide anything to slice or dice, we just get a plain value. Now let's add something to this query. And what I'm going to do is copy it, paste it down, and what we want to do is add the product subcategory or the product category to the statement, so we have something to slice it by. In the summarize, what we need to do is, after the specification of the table name, we need to provide that slicer here. So what I'm going to do is reference the product table, and in a bracket I'm going to say category and add a comma. I'm going to highlight that statement, and now we'll see the category. Oh, it's misspelled. I just have a P instead of an O. Now we'll see the summarization of product category to the reseller sales measure. Now something interesting here is that how did it get the category for reseller sales since it's not in the same table? That's where the relationships in the previous demonstration come into play. Since you have that relationship built in the model, the DAX knows that there's a relationship, and through that one-to-many relationship can do a summarize by any related attribute from a dimension to a fact table. We could expand further on it, and it seems very intuitive to do this, but I'm just going to copy and paste the product category, and instead of product category, I'm going to add subcategory here. So it seems out of order what we're doing because the reseller sales is still on the end and is not the second or third parameter. The summarize knows to go grab those until it sees the measures that's supposed to be summarized. It's very, very different than T-SQL or MDX, and it takes some time to get used to it. Now let's go one step further and add a filter to these statements we're doing. We'll start with evaluate, open my parentheses and do the summarize, and then we're going to add the filter. So what the filter is going to do is going to give us, it's going to return a table which will be just like the table reseller sales in this summarization. So basically we're replacing that reseller sales with a filter. Now my filter is going to be different than what we've seen previously. We're going to go to the customer dimension. And in the customer dimension, we're going to get the customer gender. And we're going to say equals M. So now we're creating a filter of the customer table, which is related to internet sales, but we want to filter it only for males. I'm going to close that parentheses and put a comma. And next, in the summarize, we're going to display the customer full name and the customer gender, just to see if it filtered that. And then we're going to create a new column called Sum of Sales, and it is going to be the sum of the table internet sales, but column sales amount. So instead of referencing a measure in our tabular model, now we're actually using an aggregate sum of a column sales amount to do the same thing as the measure. And after we do that, we're going to need to close our summarize, then close our evaluate, and execute this query. Now we can see we have a customer full name, the gender of male, and the sum of sales of that customer that is male.